I'll tell your mama I said, hey.
All right, I'm going to share.
She ain't here.
No. Wait a
Oh,
minute.
that's your brother. Ooh.
All right, let me share the screen with everybody. We're gonna start working on integrals. And I've got some of them written out, and some of them we're just gonna talk about. Why does it keep asking me if I want to start the meeting? Of course I want to start the meeting. Okay. All right. So guys, I've got what I call a partial key to this class exercise, the one that had 14 integrals on it. That's a lot, but it actually, and some of the problems are quite long and use several methods, but that's a good thing to look at. A good thing, where do we start? When do we say, I'm not going to give up, I'm going to keep trying to do this thing. So let me click on this and see what we got here. All right, I've got some of these worked out, but I don't want to really look at that to begin with. I want to just write the problems down and then see what I can do here. I'm gonna get some extra pages and we're gonna work on them that way. Okay, so first of all, I'm just gonna get ideas from people. Then we're gonna talk about how we put them into operation and see what happens. I am going, has everybody got this in front of them? The 1 through 14? Can you see what I was doing? Anybody? Is there anybody that can't see? All right, I'm gonna write them down, but I'm gonna look at one. Let's start off easy. Let's go for number 14.
Yeah, that one was easy.
I know, that's why I'm doing it first. I don't want to depress you right from the beginning here. All right, so that one's 2x squared plus 8. So Alexis, you jumped in first. What makes it easy?
Well, what I did was at the bottom, I saw I could pull out like factor out a 2.
All right, that's good. Get rid of as much of that as you can. So I got x over x squared plus 4. All right, what'd you do next?
And I made like the u, x squared plus 4.
Perfect. I like that idea. Okay, what was du then?
My du was 1/2. And du then it equals x dx.
Yep, I put it in the wrong place. Hang on. So you had 2x and you put the 1/2 over on the left, right? Yeah.
Yeah.
Yeah. Okay. That made that dx. Okay. So let's make the substitution. See if it works out. So I got 1/2. That came out from the 2 she pulled out up here, and then the bottom she let be u, and then the dx was another 1/2 du. Perfect. All right. She knows what she's doing. Do you guys know what she's doing? What's she going to tell me the integral of this thing is? What's the integral of that thing?
Are you asking me?
No, I want you to be quiet. I want everybody else to tell me. I'm asking everybody to tell me. What's du over u?
Log. Natural log.
The log. Exactly. That's exactly what it is. So that's 1/4 natural log of the absolute value of u. I'm going to take a shortcut and put u back in already. X squared plus 4 plus c. All right, good. That one wasn't too bad. You could kind of see what you needed to do. I'm gonna try another one. Let's do the one right before that. Let's do no, not right before that, but what number 12. Actually, guys, 13 we did yesterday, most of it. That was the one where we let u be. It might not have been that. It might have been the square root. I'll work on that one too. But let me work on 12. Let me work on 12 for right now.
I always making stuff up, so
Okay, so 12 looked like this. Sine 2x, cosine 7x, dx. All right, not Alexis. Anybody else tell me what you want to do with this one? Where'd you go? What'd you look at? Anybody? Guys, this is a dead giveaway because those two angles are different, 2x and 7x. This was in that 9.2. Anybody want to tell me what they did? All right. See what I'm holding up here? My cut up book. All right. See that back page?
Yeah.
There are those formulas back there. They're called product to sum formulas. And this one, there's a problem back there that says sine U cosine V. This is really, guys, this should be the easiest thing on the test. Go there, use the formula, you got it. But here's what the formula says. Sine U cosine V, which is indicating that they're different. There's your U, there's your V, all right? The formula says 1/2, and they're called product to sum formulas. And that one says sine U plus V. I don't even know these things, guys. I just know when to use them, and that's all I need. Sine U plus V, and then plus sine U minus V. Sine U minus V. I might have done one of those in class. I probably didn't do more than one, but that's where you need to go. There's my U. There's my V. So if I write that according to this, I'll have the 1/2. What's the sine of U plus V going to be? What's U plus V going to be, guys?
9x.
9x. So it's sine 9x plus the sine. I'm making sure I did the thing right here. What about U minus V? What's U minus V in this case?
Negative 5x.
Negative 5x. Okay, guys, here is why this thing is called product to sum. It took a product that you couldn't integrate, and it changed it to the sum of two things that you could. Can y'all am I covering up part of what y'all need to see? We'll get this out of the way. There we go. Okay, so let's write down what we got. That's going to be 1/2 sine 9x. Now, be careful right here. You can pull a negative through a sine. Can't pull just any old number, but the sine of minus an angle is minus the sine of the angle. So I'm going to do that because that makes that look much easier. Okay. Those formulas are also on that back page. They're called formulas for negatives, and they're all right up at the top. Now, keep in mind that you're going to have your book with you, and you're going to be able to use the book. So you just have to know where to go to find what you need. All right, let's finish it up because it should be easy. What's the integral of sine 9x, guys? Go backwards. Whoops, yeah, there's the integral. What's the integral of sine 9x? Anybody? Negative cosine 9x. Be careful when you're going backwards from sine. It's negative over what?
9.
Over 9. Good. Because we would multiply with a derivative. We're going to divide with an antiderivative. How about this one? Also going to be minus cosine 5x over 5. And then we're pretty much done. Minus and minus will be plus there, and then you got it. Okay. Okay. So what I'm trying to tell you here is when we have this test, I'm sort of going through looking the ones I think are obvious, okay? Because I want to get a good confidence boost here, okay? And I'm going to look for those, and I'm going to do those, and then I'm going to go back and maybe work on the ones that look a little harder. Now, also what will be available on the test, of course, you have your book and your notes and so forth. I will give you more integrals than you need to do. For instance, I might say, here are 12 integrals, do your favorite 10, and then I'll give you extra credit for the other 2, okay? So I'm kind of cushioning things there. If you can do one, great. Can't do the other one, just leave it, okay? Give you a little bit of leeway there in terms of what you do. But I'll give you extra credit if you do, if you did 12 of them, I'll give you extra credit. Okay, so anybody that's looking at the page, do you see any more that you think are kind of obvious? Do you see any more that you think are, which one? Who's anybody looking at not, that's a blank page. I'm going to write on that. Who's got the actual sheet in front of them? Anybody? Okay.
I wrote down all the integrals.
Okay. Yeah, all the integrals is what I'm talking about. Tiara, take your mute off and tell me one you think is not going to be so bad. Just glance at them and see, and we'll make you make the decision right now. I'm kind of looking at them too. So we've done 12 and 14.
I mean, number 1 doesn't look bad.
Okay, all right, we'll try number 1. What do you think? How do you think I need to start off with number 1, guys? Anybody?
Parts.
Parts. I absolutely agree with that. I'm going to go back because I actually did that one. I want us to look at it because it looks easy, and it does start off pretty easy. But this is an example of where you got to be persistent here. Parts is exactly the right place to go. And you want to let u be that inverse trig function. You want to let dv be that x squared. This is easy to take the derivative of. I should have put a dx right there. Okay. And let's see if I can do this. And the other one is easy to integrate. Okay. So I got x cubed over 3. So here's how the parts goes. uv, so u and v, minus the integral of v du. And there was my du right there. Now, the thing that you've done parts great, you've got something else to integrate though. So let's look at that. You already got one piece of it. Is everybody seeing where I am right now? When you get to this piece, if this thing right here had just been a 1 and there'd been an x up here, by the way, this is a square root of 1 minus x. That's what was down there, okay? I kind of forgot it when I wrote it. Then it would be an easy substitution. Problem with this is it's an x cubed. You're like, I got too much stuff up there. I want an x up there. I don't want an x cubed. So I got to say, okay, if this were a problem all by itself, what would I want to do with it? Well, in the absence of anything else to do, see this square root of 1 minus 8 squared? That looks like a trig substitution for me. So, okay, we started out with parts. We got part of the way through. You got some partial credit here, okay? But then you got to do something with this one. So I'm going to go over to the side here and try to do that one. Okay, so in other words, I'm going to try to do, let me block it so you can see. I'm going to try to do this one right here, like it was just a problem all on its own, okay? All right, is everybody with me so far? Seeing that parts got me part of the way, but it didn't get me all the way. All right, so so while it looked easy initially, it's kind of morphing into something a little harder. So suppose I said, I'm gonna, what would my trig substitution be for this? We let x equal 1 because it was 1 squared here. Oh yeah, and I get 1 sine theta. I make my triangle, because sine is x over 1, so that's opposite over hypotenuse. And this will be on the recording, guys, so if you just want to watch me, you can, but it's that. And then that side will be square root of 1 minus 8 squared. So if x is sine theta, dx is cosine theta. Darn it. I did this in a hurry. So that's a theta. That's a theta right there. Okay. So, so I'm going to make my substitutions. Okay. Interesting here, because x cubed. Well, remember, x was sine. So I'm going to put sine cubed right there. dx was cosine. I'll put that there. Square root of 1 minus x squared was 1 minus sine squared. Things are looking up, sort of. That cosine, that's a cosine squared. So square root of cosine squared is cosine. Those two go. They are gone. All right, so things are looking okay. Sort of. Okay. So I went from parts to trig substitution. Now, let me pause right there. Is everybody okay with what I did to try to go from here to here. I did a trig substitution. I'm keeping this all the way because it's part of what we started out with parts.
Like,
Okay.
I think where I messed up at was like, I don't know, man.
Well,
Honestly, I tried to do like long division because I didn't see the
No.
trick. Like, this wasn't obvious to me at all.
yeah, okay. And no, it's not obvious because you have to do a bunch of things. It's not long division because it's under a square root there. You
Oh,
can't do that, okay? If that hadn't been under a square root, that's what I would have wanted you to do.
okay. 'Cause
can't
I
do
was
it
just
under
like, I
the
could not get any further.
Yeah.
I was
Well,
just like,
okay. Anybody else? Anybody else have any issues to this point? Okay, now what we got, this is a great problem. I might be able, I mean, if I had you in graduate school, I might give you this problem and say, hey, this is the only problem on the test. Have at it, because it's got a bunch of stuff in it. So here's where I am right now. I am right here. And now what I've got to deal with is that. Okay. Well, that's one of those things that was in 9.2. And it was an odd power of sign. And what we said with this odd power of sign business, that we were going to split off one of those signs. So I took one of those signs and was left with two more here. Now, remember why I do things. Why did I split off a sign? So it could be what?
sine squared.
Yeah, so it could be like so it would be a sine squared left. That's right. I did this in a real hurry. This theta's here. But the sign that I split off, I want to serve as part of my du. What is the sign the derivative of? Sort of. I mean, close. Which function should I put this in terms of?
Cosine.
Cosine. Exactly. Okay, so here's what I'm going to do. I split off that sign. It's right there. I took the sine squared and I wrote 1 minus cosine squared. Now, I think I'm in pretty good shape at this point, because now what I've got to integrate is this thing right here. Pretty clear that if I let u be cosine, my du will be in there, except there will be a minus in there. Boy, I shouldn't have. Okay, so that's where we are right there. I got in a big hurry here. Okay, so I'm gonna go back and make that substitution. Sine theta was minus du. So that's where I put, for sine theta, I put in minus du. See that? Sine theta, d theta. There was a minus, so I'm gonna put it over on the other side. Now what's left here is 1 minus u squared. Okay. I'm kind of seeing the light at the end of the tunnel here, guys, because it's getting easier and easier. I multiplied through by the minus, which gave me a u squared right there and a plus 1 right there. So, oh, tell me I didn't do this, mess this up. Okay, no, I didn't. Minus a minus gives me what here, guys? With this minus and that minus, it gives me a plus, and then I don't have to worry about anything in there. I took the minus out here, I got a plus. Look at that. Easy to integrate. What's the integral of 1, guys, with respect to u? Well, it's just u, and the integral of u squared is u cubed over 3. Okay, I'm done integrating, but I got to go back where? I got to go back to x. So here's what I'm going to do. I'm going to sort back through the problem and say, well, what was u? U was cosine. So I'm going to put in a cosine wherever there was a u. Great. The next thing but that's only in terms of theta. So now I've got to figure out how to go back to x from that. And I'm going to go back to the triangle. All right, I'm going to go back to the triangle. And what I need is cosine theta. Look at the triangle. What's cosine theta, guys?
Square root of 1 minus x squared.
Yep, over 1. So it's adjacent over hypotenuse. So that's where that thing right there came from. Whoops. And the other one is also a cosine. So I put in square root of 1 minus x squared. I cubed it over 3. I'm done. How many techniques did I use there, guys?
Like 4, maybe 3.
Yeah, well, actually I used parts. Then I used trig substitution. Then I used blah, blah, blah. What actually was the trig substitution next? Yeah, trig substitution. And then I used just a general kind of split off a sign, just a trig trick, a trigonometry trick. So, no, I'm biased, perhaps, but I think these things are kind of fun because it's like a puzzle to solve, okay? It's like I'm gonna start down this road and see if I can get to where I wanna go. And a lot of times it takes a lot of forks to get to where you wanna go. So I had to fork off here to do another method. Then I had to fork off here to do another method. And finally I got to where I was going, okay? Okay, that's a tough one. Tiara didn't know that when she started it. She started at the right place. There was a lot to do with that one. Anybody have any questions about that one? All right. Okay. Somebody else give me one. Dion, you got it? You got the problems in front of you?
Yep.
Okay, what you want to do? Give me one you want to do. Make it easy so you can do it.
Oh, I had a question on one.
Okay, which one?
Number 8.
All right, good. Actually, let's look at number 8, guys. Because actually, that one's not that bad. All right, we'll do number 8. Okay, so when you started it, Dion, this is kind of your problem. Tangent x, secant to the 6th of x, dx. When you first saw that, what did you think you might have to do? What do you think? When you think about tangents and secants, what do you think about some derivatives of tangents and secants? What do you know? You got to know what you know.
I don't know.
All right, guys, there's a tangent in there. I want everybody to tell me what the derivative of tangent is.
Secant squared.
Secant squared. So I look at that and I say, you know, I might be able to pull off a secant squared and change things to tangent. There's another option though. What's the derivative of secant?
Secant tan.
Secant tan. I think either one of those will work. But I think probably the easiest thing to do might be to peel one of these secants off here, and then that'll just be left with secant to the what? If I peel that off, what'll be left there?
Secant to the 5th.
Secant to the
5th.
5th. Yep. Okay, so let's try it. And then you might want to try it the other way. It may work the other way. I'll show you how I might think about it the other way too, because some of these can be done more than one way. And this is in 9.2, and it gives you little ideas about what you want to peel off about things. So when you do problems, if you don't remember it, go back and look at it. What did they tell me would work? So I'm going to peel off a secant, and I'm going to be left with secant to the 5th of x dx. So what was the point of that, guys? What do you think I want you to be here?
Secant.
I want it to be secant because when I pulled off that one secant, it gave me the derivative of secant. So du, I've set myself up perfectly here. I've got secant x, tangent x. Okay, good news. That's not a bad one if you see that. So that secant x, tangent x is my du, and my secant is secant to the 5th, so that's u to the 5th. This problem could not be any easier if you go there. Okay? So, what's the answer here, guys?
6.
U to the 6th over 6. And then I'm going to put my u back in. Secant to the 6th of x over 6 plus 6. Okay, let's see if it would have worked the other way, because there are other options. Questions about what I did there, guys? So when you look at these things, you're kind of trying to peel off something to be your du. Any questions about that? I'm gonna try it the other way. Let's try it the other way. So this is an alternate way, and I don't know if it's gonna work. I don't know if it's gonna work. I'm gonna see. Okay. So somebody said, let's pull off a secant squared. So that'll leave me the secant to the 4th of x times secant squared x dx. So because I peeled that off, what would all of this need to be? Whose derivative is secant squared? Why would I have pulled off a secant squared? So it could be the derivative of what?
Tangent.
Tangent. So I need to see if I could change all this to a tangent. All right, let's see if we can do it. Do I have an identity that connects secant and tangent? Do I have an identity that connects secant and tangent?
Yep.
Plus tangent.
This
squared.
book right here, see the back cover? I'm destroying. I see it something that says 1 plus tangent squared is
Secant squared.
secant squared. So I'm gonna say, maybe that'll work. 1 plus tangent squared is secant squared. Okay, so this is already a tangent. That's a secant squared. So I really need to write this as secant squared squared. And then I'll leave my other secant squared over there. But remember, that's going to be serving as part of my du. Okay, I'm feeling pretty good about this. Although already I'm thinking this isn't as easy as what I just did. Okay, but it'll work. I think it'll work. So there's tangent x. Secant squared is 1 plus tangent squared. Oops, 1 plus tangent squared, and all of it squared. And there's the secant squared x dx. So what am I going to let u be here, guys?
Tangent.
I'm going to let it be tangent, right? That's why I split that secant squared off. So let u be tangent. So du is secant squared x dx. So start making your substitution. U 1 plus u squared squared du. Okay, I'm really almost there. If when I see something like that, I'm like, maybe I can do that. How? What do you think I want to do here? What would make it just a string of power rules?
Multiply it out.
Yes, multiply the thing out. So let's do it. That's going to be u times, what's that going to be? 1 plus 2u squared plus u to the 4th. And did I multiply that out right, guys? I think so. Then I'll just finish the multiplication. So now switch pens. It'll be u plus 2u cubed over 3 plus u to the 5th over 5. No, wait. Well, I'm sorry. I'm doing too much in one step here. Hang on. Let me just give me a minute. I'm just multiplied it out yet. I was trying to multiply it out and do it all in the same thing. That's 2u cubed. 2u cubed. And that's u to the 5th. Anytime you can use algebra on it to make it easier, to make it a real easy problem, do it. So what's the integral, guys?
U squared over 2.
U squared over 2 plus
Plus
2u to the 4th over
4,
4 plus u to the 6th over
6.
6 plus c. Then I got to plug what back in?
U
Where was I? What do I got to plug back in here, guys?
tangent.
Tangent. So that's tangent. Dang it. Wait a minute. That's tangent squared x over 2 plus 1/2 tangent to the 4th over nothing, because I reduced that 2/4. And this will be tangent to the 6th of x over 6. Now, that was harder than the first thing I did. And not only was it harder, you look at the answers. The answers look very different. There's the answer when I did it that first way. There's the answer when I did it the second way. They don't look the same, but you know what? They're trig identities. But I don't care. I mean, I'm not gonna take the time to show that they're the same. That would be a problem for trig class, okay? But my point for that being, the book might have done it one way, and you did it another way. If you feel confident about your way, don't worry about the answer in the back of the book, because they could have done it a totally different way. A good practice would be to say, well, could they have done it a different way from me, and tried that way. Okay, so there's another one. All right, how about anybody see? Okay, that was Dion's. Anybody see another one? So we've done 1, we've done 12, we've done 14. We just did the tangent, we just did 8. So somebody toss out another one and tell me what you think you want to do with it. Toss it out quick, please.
10.
10.
I was about to say that.
Okay, good. Everybody's saying 10. Actually,
Okay, so
I
this
like
is me
10.
and Dion.
Okay, so here's 10. Okay, let's see. What do we got? E to the 3x over 8 e to the 3x minus 6 dx. Now, I want everybody to take a second to look at it and ask yourself the first question: is there anything obvious that might work? Is there any just plain old, no problem substitution that might work on this thing? What you got in the numerator?
E to the 3x.
And what do you got? A bunch of stuff in the denominator, and what's it got in it?
I think that's the derivative.
Oh, yeah. Okay, so Tiara just said, oh, well, if you just look at this thing, you see that if you were to differentiate this, you would almost get what's in the top, wouldn't you?
Mm-hmm.
It had an e to the 3x in it. So what do you think, before I do it, what are you thinking this is going to be?
Law.
No, yeah.
Great, natural log. Now, so what are you going to let u be? What are you going to let u be? Anybody?
E to the 3x.
Hey, yeah, tell me, give me. Okay, my internet connection is unstable. All right, whatever. So far, it keeps telling me that, and it doesn't ever have any results. But I'm gonna let it be as much as you can, without any damage. And what I mean by that is, you don't want to just let it be this one, because you gain something. Derivative of 6 is 0. So you don't have to worry about that. So what is the derivative right here, guys? Tell me what the derivative right there is.
E to the 3x over 3?
E to the 3x. I got to multiply by 3, though. So,
Oh, yeah. Mine divided by
3 e to the 3x over 8.
yeah, 3 e to the 3x, but it's got an 8 there, doesn't it?
Mhm.
Yeah.
So what's it going to be, actually?
24.
24 e to the 3x, right? Everybody good with that?
Mm-hmm.
And then the derivative of minus 6 is 0. Okay, I'm looking at everybody's face. So what's, and that's dx. So what am I looking for? I'm looking for e to the x dx, e to the 3x dx. So that's what I leave over here.
Hmm.
And what's it equal to?
124.
1/24. Now, I've seen errors, guys, when you forgot to flip this and you just moved the 24 over there. Don't do that. You're dividing by 24. Yeah, Tiara's laughing at her. Yeah, okay. So here, I'm gonna make my substitution. E to the 3x dx is 1/24 du, and down below is u. Boy, that's nice. What's the answer? 1/24 what? 1/24 what?
Natural log of 8 e 3x minus 6
Yeah, that's right. Natural log of
plus
u,
c.
which and plus c. Thank you. E to the 3x. That was my. No, wait a minute. What was my u? Hang on, I messed up. What was my u again?
8e to the 3x
That
minus
was
6.
8e to the 3x. Okay, 8e to the 3x minus 6. And plus a nice c. Okay? It always made me really upset in college when I was taking Calc 2. And I would do this beautiful integral, and I would forget to put the plus c. My professor would put -1. I'm like, look at all that beautiful work I did. You're going to take off -1 for plus c? Yes, because it's important. So if you want, when you're doing this, you probably should write at the top of your paper, don't forget the plus c's, and you just go put plus c's on everything, okay? Okay, so everybody good with that one? Somebody pick another one. Pick one you think, oh, actually, the rest of them, well, pick another one. Somebody, quick. Pick another one you want to talk about.
Can we
Yeah,
do
but pick-
number 2 because I don't know how to do the long division still.
No, yeah, let's look at 2. That's, okay, let's look at 2. So look at 2 looks like this. The integral of the cube root of x plus 8 over x. Now, somehow I've gotten Alexa on a tear with division. I can't divide here because all of that stuff right there is under the cube root. Can't do it.
Well,
Okay.
did
Isn't
that
this
wrong?
Did I write that wrong? Yeah. It's the cube root of x plus 8 over 8. If there hadn't been a cube root there, I would have liked her idea. Because x into x will be 1 plus 8 over x, 2 easy things to integrate. I don't like that idea if there's a cube root there, because you can't get this x right here up under that radical. Can't do it. All
I don't
right.
know, I keep getting confused.
so?
It's okay. It's okay. You get good at these things by working it and making mistakes. That's why we're doing this. That's why I'm allowing all these days for when we just work on these things. Anybody got an idea?
Miscellaneous?
I think a miscellaneous might work
That's
well,
good.
actually. The question here, guys, is what do you need? What do you need as far as miscellaneous goes to do this one? What do you think? What's causing me the problem? What's causing me some problems here?
Cube root?
That cube root. That triggers something up here that says, well, you know, I wouldn't want to let you be what's under here.
Let it be the whole thing.
Okay, all right, I like that idea. Let's try it. Let's let it be the whole thing. So I also kind of don't like it like that, but I can fix it. Because
Cube
remember,
both.
I could get rid of the cube root. What can I do to get rid of the cube root?
Cube both sides.
Cube both sides. Everybody with me? So I'm going to cube both sides. That gives me a u cubed x plus 8. That tells me if I take du and dx, what's on the right-hand side?
3u squared du.
All right, 3u squared is on the left. And what's on the right is
Yeah.
dx. All right, I am making progress. Watch this one carefully because this is where a couple of you had questions yesterday about how I finished up the substitution. So does everybody understand what I've done on all 3 of those steps? Okay. So here's what I'm going to do. That was just u. Dx was 3u squared du. So I've substituted for that. I've substituted for that. What's the only thing that's left?
X.
The x. Do I have a way to get a hold on what is x by any one of these things in terms of u? Do I have a
Yes.
way to get a hold on it? What is it?
The second, the u cubed equals x plus 8.
Yes. So what is x, guys?
U cube minus 8.
Good. X equal u cubed minus 8. So I'm going to put that down there. So u cubed minus 8. So that's 3u cubed over u cubed minus 8 du. Okay. So is everybody with me so far? What do you see there? Tell me what you see. Tell me what you see there. What's it called when I have just one polynomial over another polynomial?
Right.
It's a rational function, okay? It's one of those things we might have looked at with partial fractions. However, the power in the numerator is the same as the power in the denominator. So while I made it look better, I still have work to do. Tell me what that work I've got to do is.
Long division.
The long division. So let's try that. These things will put you through your paces, guys. So I pull the 3 out because I don't want to mess with the 3 in the long division. Pull any constant you can out. All right, so let's look at it. Let's do a little more long division here. An extraordinary amount of long division happened in this exercise. I didn't necessarily mean for that to happen, but by the time we finish, you'll know how to do it. Okay, what is u cubed into u cubed? This into that. What's u cubed into u cubed, guys?
1.
It's just 1, isn't it? When I say u cubed into u cubed, it's just 1. When I multiply back out, I get that. So u cubed minus 8. I subtract, I'm left with 8. And you know what? I am kind of done with the division. So the integral looks like 1 plus the remainder is 8 over u cubed minus 8 du. Let me make sure I got that right. U cubed, I multiplied out, I subtracted minus 8, made it a plus. So plus 8 over u cubed minus 8. Well, I can integrate half of it. What's the integral of half of that one, that piece? What's the integral of 1?
U.
It's just u. So I'm making progress. This is what you always got to tell yourself. However, I got this thing to deal with. So let's look for a minute at what I might do to 8 over u cubed minus 8. Because that's the piece I need to worry about. Now what does it look like to you guys? It still looks like a rational function, doesn't it? So what do I use? Sometimes what do I do on rational functions? If the power in the numerator is lower than the power in the denominator, what do you think when that happens?
Partial fractions?
Yes,
I don't know.
partial fractions, absolutely. Partial fractions. And guys, on that guide sheet that I gave you to give you hints on how to do things, you'll see hints about that. So this is going to be well, let's don't do that yet. Hang on. I got to factor this. And here's where your algebra becomes critical. And this is a tough one, guys, because I think this is sometimes one that not many people think about. It's the difference of 2 cubes. It's the difference of 2 cubes. Here's how you factor the difference of 2 cubes. I'm going to give you the formula here. So if you need it again, you'll have it. The difference of 2 cubes, x cubed minus y cubed factors into x minus y times x squared plus xy plus y squared. And if it's the sum of cubes, these two signs change. You can look it up. You got everything, the world's in front of you. Anything you need to know, you can find it. So here's how this would factor. What are the things that are cubed right here? What are the things that are cubed right here?
U.
U and 2.
U and 2. So here's how I'm going to break it down. U minus 2, then it's going to be u squared plus 1 of each, which will be a 2 and a u, plus the second thing that was cubed, which is 2, and that's 4. Does everybody see what I did? the 2 and the u are my x and y here, and then my y is 2, so I get a 2 squared is 4. All right. So everybody good with that? Now what? Now what? Why did I factor it? Why did I factor it, guys?
To do partial fraction.
Do partial fractions. So what I might do here now, and I may let you guys do this so I can move on to maybe another one. So it looks like this, u squared plus 2u. By the way, when you factor a cube like this is an irreducible quadratic. Irreducible. It's a little less recognizable than the ones like x squared plus 9, but if you try to put that in the quadratic formula, you're going to get a negative under the radical. So you cannot factor it, and it doesn't have real roots. So that's equal to a over u minus 2 plus, if this is an irreducible quadratic, what you going to put in the top there, guys?
Bx plus c.
Good, 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 good. Bx plus c. Then you're going to clear things through, do what we always do, and find out what a, b, and c are. Now, when you get to this point right here, this might be a little tough to do. I don't know exactly what happens in that. But I'll work it out, and we'll come back and make sure everybody got it worked out right. Or I'll put it on Moodle or something. But I'm pretty, if I find A and B, I know I can do that part of it. This part, I would probably want to split up into 2 pieces, just depending on what happened there, but we'll see. It might be that, I don't know. I don't know what's going to happen. And this, and by the way, it wouldn't be a BX, guys. What would it be? What's the variable in this problem?
U.
It's a U. Yeah, thank you. So I'll put a U there. Okay. So finish this one. Go ahead and try and see if you can finish that. And I'll try to finish it too. I don't think I have it in front of me. I was looking and I don't think I have it. Okay. So let's go. We got another minute. So everybody pick one. I tell you what. Somebody pick another one. Or I tell you what I'm going to do. Here's what I'm going to do. I'm going to write the ones that we didn't do, and then I'm going to give you. We're going to see if we can figure out a starting place or a hint about a starting place. The first one I didn't do here was 5 cosine x, and this is number 3, over sine cubed of x dx. And that's number 3. What do you think? Somebody give me a first idea for this thing.
Pull out the 5.
Pull out the 5. Absolutely. I got no problem with that. That's a good idea. So I'm just going to pull that 5 out. So all I have to worry about is this. Anybody? Good idea.
Break off a sign.
I don't want to kind of break off signs that are in denominators, but notice you do have a sine cube down there. But what you got in the numerator?
Cosine x.
So what if I wrote it like this? Would you recognize it? What if I wrote this function like this, which would be the same thing? What if I wrote it like that?
Cosine u.
Let u equal what?
Sine x.
Do you have a du for any of this stuff? What's the interior function at the bottom there?
Oh, sine x.
Sine x.
Sine x, yeah. So we're going to let u be sine x. And what would du be?
Cosine.
Cosine x. And I got a real easy problem there. Because that's 5. This is a cosine right here. Cosine x dx is du. And what's this going to be?
U cubed.
U cubed. I got an easy problem there. Did everybody buy that? All right, let's look quickly at, I did it, I didn't, and you can finish it. That one's easy to finish. What about this one? 8x, I don't think I did this one. Square root of 16x squared minus 2. What you want to do with that one, guys?
Trig substitution.
Say it again, Tierra.
Trig substitution.
You know what? I don't like trig substitution. I'll tell you why. That's not really a perfect, that's a perfect square there, but this 2 isn't. I think there's an easy way. Look for the obvious way first. What if I rewrote it like this for you, which is something you're going to want to do, over 16x squared minus 2 to the 1/2. What if I wrote it like that for you? Is there any obvious substitution that might work here? Remember, you want to let u be something so your du is somewhere. We could have done this in Calc 1, guys.
So can't we just make the 16x squared minus 2u and then move that coefficient over, and then you'll have an x left?
I like that idea. Okay. So I'll have 16x squared minus 2. Du will be 32x dx. But you know what? X dx is what I need. Pull that 8 out of there. I don't care. There it is. What is x dx? Do it right, Tierra. Don't get a good idea and then mess it up. All right, what is it?
Oh, 1 over 32.
Perfect. So that's 1 over 32 du. And down here is u to the 1/2. What you gonna do on that, guys?
Bring it to the top.
Bring it to the top, use the power rule on it. Bingo. Guys, I'm kind of out of time, but I'm just gonna real quickly look at the rest of them, and I'm not gonna do as much as I did here. I'm gonna sort of throw out some ideas, and then we'll call it quits. The next one was 5. If you got to go, let me know, and I'll close down. But see, isn't this fun? Y'all
Yeah.
smile. Okay, 25 plus x squared dx. This ain't gonna work like the last one, because if you let u be this, you got too much upstairs. You got too much up there. Now what might be a good idea here, guys?
Trig substitution?
Yes, absolutely. What do you want x to be?
1? I don't know.
What's your thing that's squared here?
Oh, 5.
5, and this is a tangent, a sine, or a secant?
Tangent.
There you go. All right, so let it be 5 tangent x. Then go from there. All right, if we look at 6, how about this one? 7 over x squared minus 6x plus 18. What's the first thing you're going to try on this, guys?
Factor the denominator.
Look at the denominator and ask yourself, will it do what?
Factor.
Will it factor? I'm going to tell you right now, it ain't going to factor. Do I have another option? This is the one I hadn't quite. If it won't factor, does this ring any bells if I move that 18 out of the way?
Quadratic.
The quadratic form. I'm going to make a perfect quadratic out of it. Take half of that, square it. Actually, I think I might have done this in a different time. That thing will end up being x minus 3 squared. This thing will end up being plus 9. I think I did this before. It looks familiar. What's your substitution going to be if I do that? Let x minus 3 be what? There. What do I square to get 9? 3. Is it a tangent, a secant, or a sine? X is something squared plus something else squared, a tangent.
Tangent.
Or a secant. It's a tangent. So I'm going to let it be 3 tangent theta. All right, we are 7's easy. I'm not even going to do anything on 7, but I'll write it down and let you tell me what you're going to do, because I think it's probably one of the easier ones. 7 looks like 4x squared minus 6x minus 4, and it's all over. Actually, I was very nice and factored this thing for you anyway, and that was x minus 2. What you going to use on this one? And that's all I want to know. What you going to use?
Partial fraction.
Partial fractions. Power in the numerator is less than the power in the denominator, because if you multiply it out, you'd have an x cubed. So this would be partial fractions. We are. Say what? Oh, is that who's talking to me or not talking?
It was my grandmother asking if I could see in the dark.
Okay.
I said, why don't you open the
You don't
curtain?
need, yes, she can
I'm
see in the
okay.
dark. Okay. So guys, we did 8. We did 8. Let's do
I'm so
9.
sorry.
Okay. Let's do 9. Okay. So on 9, I've got sine to the 4th of 3x. All right, here's what I'm going to suggest. Even powers of sine. Sine squared of 3x squared. When you have even powers of sine, you're going to go looking for a half angle formula. Go back and look. Half angle formula.
That was so mean.
What? Of who? Me or your grandma?
Oh, sorry. Still talking about grandma.
Okay. Okay. We've already done 10. 11. I'm going to leave 11 for you to look at. 11 was cotangent squared of 4x. You don't know how to integrate cotangent squared, but I think you can change that to something you do know how to integrate. So that one's done. So try it again. Finally, we did 12. We did 14. 13 was kind of a mess, but it was that miscellaneous substitution. And we'll start, it'll be 1 or dx over the 4th root of x plus the cube root of x, and my substitution should be u equal x to the 1/12. Where'd the 12 come from, guys?
You multiplied the 1/3 and the 1/4.
Yeah, the 3 and the 4. If you raise this to the 12th power, you get u to the 12th equal x. Then dx is 12 du, 12 u to the 11th du. Plug it in. You're going to get something you have to long divide. It's not bad if you can just finally figure out how to long divide it. Finish up the ones that we didn't finish, and we will do that tomorrow. We'll start on that tomorrow, okay? But what you see from this is that there's lots of methods. There are lots of things that you're going to have to think about when you start doing these things. Where do you start? Where do you go from there? Anybody got any questions? So the homework tonight, really no new homework. Finish up what you got here. Look at what we've done. Look through all your methods and say, okay, I'll do this one when this. I'll do this one when that, and so on. All right. I'm going to post this so you guys can look at it. It's a big mess. I hate to post it. I hope nobody else looks at it. Are we okay?
Take-home quiz.
Somebody talking to me? Alexis, what you saying?
Do we have that take-home quiz due? Like, there's a take-home quiz that you said was due. Like,
Yeah.
you told us it was due yesterday.
It was due, that was the one on 9.2, right? The one on the trig parts, trig things, not parts, but trig break-offs, things, breaking off things. Do that. Try to get it to me before class tomorrow, okay? I think you'll be able to use them as extra exercises tonight, okay? Because all I want you to look at tonight is the rest of these. And then any other ones in that section of 100, just do the same thing we did with these. What would I try here? What would I try here? Is that clear, everybody? Thank you for letting me keep you a little longer. I didn't want to stop because I wanted you to be able to see where we would go with everything. All right, everybody ready to go?
I have a question about the homework from the other day.
Okay, Tiara, if Tiara wants to stay in, that's fine. She's going to ask me a question. If anybody else needs to leave, y'all can leave. I'm going to, and any questions she has, like Deborah, what's that?
Oh, I was just saying, but I gotta go.
That's fine. I know you got to go to work, so that's fine. You can look at the video and see what she asked, okay? Okay, so you can sign it. Lexus, Dion, if you want to stay, you can stay if you can, okay? All right, so let me see. What Tiara, oh, I lost my screen. There we go. Tiara, what is it that you want to ask me?
So I was looking at the homework on the quadratic expressions.
Yeah.
And I could only get 2 of them.
Okay, well, tell me one you couldn't get.
It was number 9. It says the integral.
Okay, read it to me.
The integral sign 1 over
Mhm.
x squared plus 4x
Mhm.
plus 5x, and that entire thing squared.
Plus 5x or 5?
Plus 5, my bad.
And then I squared it, right?
Yes.
What page was that on?
479.
479. All right. I got all the cut up pages out of my book flying around. I'm going to regret that. So this was number
9.
9. Okay. Wait a minute. Oh, here it is. 1 over that thing squared. Okay, now, let me tell you something about what they did in these problems.
Okay.
What they did was teach you a new method, and then they tried to sneak in one on you that wasn't that method. Because first thing you're going to look for in this one is, will that factor? Okay, so that's my question to you. And I don't need to complete the square on this if that'll factor. So tell me if that thing inside the square, don't worry about the square right now, we'll worry about the square in a minute. Will that thing factor? Will x squared plus 4x plus 5 factor?
Yes.
Tell me what it'll factor into. Let's see, I need an x and an x.
Mhm.
What else
1
do I
and
need?
5.
A 1 and a 5. Actually, and I don't know if it'll factor or not.
Right.
It won't factor, will it?
Because it's too, they will want them both to be positive.
Yeah, I know.
So we wouldn't be able to get the 4.
So yeah, if both of them are positive, it doesn't give me what I need in the middle. And if I make one of them negative, it
But you
doesn't.
can't because of that.
Yeah, I can't because of the 5.
Yeah.
Ooh, that's interesting. Okay, hang on. All right, hang tight for a minute. So I was just checking. You copied it right. You got it right. So let's go. What am I going to do?
I don't know.
I don't know either. Let's try. I really don't. But I do know that maybe what I need to do is do this quadratic expression thing. But keep in mind what I said. Sometime, if that had factored, I wouldn't use quadratic stuff on this thing. All right, so here's what I'm going to do. I'm going to take the x squared and the 4x, and I'm going to move the 5 over there. Okay? And then I'm going to complete the square. Tell me what the formula is for completing the square, guys.
You take the value that's on x and you take half of that,
Uh-huh.
and then you square that.
Okay, so half of that is 2. So I'm going to add 4, but in the same breath, I got to take away 4 because I can't change the balance of the equation, okay? You guys understand that because you're chemistry people. So I group these now, and I group these. So it's going to be x plus 2 squared. And this one will be plus 1.
Oh, that's where, okay.
Yay! Actually, I like that. Why do I like that, guys? It worked out better than I thought it was going to do. Forget about the square for a minute. You can deal with the square later.
Mm-hmm.
But if you just had this, tell me what you would do.
Where did the 2 come from?
Where did 2 come from? What 2?
Like the x plus 2. Like I don't know how we got there.
Oh, look. Anytime you make that formula, do that completing the square, this will factor into a perfect square. So that'll be x, 4, 2, and 2. It would give me a 2x in the middle, and that's what plus. That's how I got that. That's, guys, that recipe, that's a recipe for cooking up a perfect square. And the perfect square that gets cooked up, when you half this, if you get plus 2, that's the perfect square, x plus 2 squared. Okay, Alexis, you got it?
Yeah.
So you grouped this so it would factor, and you cooked up a perfect square. Okay, let's everybody, you guys okay to hear? Tell me what that looks like. Tell me something you might want to do on that. You got something squared plus something else squared. Forget about the square on the outside. Let's just hone in on the inside. What do you think?
So,
If you had something squared plus something else squared, that ought to start ringing bells here.
I mean, I said trig substitution, but
And that's right.
um,
And that's right. Trust yourself. Okay? I think it's a trig substitution. Tell me what you think the trig substitution ought to be.
tangent. So
Here's the thing that's squared plus another thing squared. So let what?
x plus 2
Yes, equal.
tan whatever tan theta.
Yeah, it's tan theta. And what's the coefficient on it? It's because that's the one
One.
squared. That's the A, isn't it? You're dead on. You're right. Okay. So it's 1 times tangent theta there. Okay, let's start seeing what we can do with it. What's dx? What's dx?
Secant squared x
Yep. Actually, secant squared
theta.
theta d theta. Okay. Alexis, are you with us? You understand why I did that? Because it was something square, something in the form x squared plus a constant squared. Okay. That's why I kind of rode you guys on that trig substitution, because it pops up a lot. All right, let's see if we can substitute. I don't know what's going to happen. Again, let's see. dx was secant squared theta d theta. So I got that substituted for. X plus 2 was tangent. So that's tangent squared theta. Tangent squared theta plus 1. And it's all squared. Okay. What is tangent squared theta plus 1, guys?
Secant squared theta.
Yeah, I kind of like that. So that's secant squared theta. Now, here's on the top still. This is secant squared squared. So actually, what's there?
Secant fourth.
Secant to the fourth. Okay, all right. What? Now I got one obvious step to make, and then an easy step, and then I'll worry about the rest of it. What's secant squared over secant to the fourth?
1 over secant squared theta.
Yeah, that's just algebra. Because I can cancel 2 of those. Now remember, you're going to have unlimited time, so it's to an extent, and you're going to have your book with you. So if you get stuck at some point in these things, walk away. Just walk away for a little while, and then you'll probably have a revelation or something. I don't know. We'll see. Do you see anything I could do to make 1 over secant squared look better?
1 over cosine
1 over
squared
secant?
theta.
It's cosine squared, yeah. Because 1 over secant is what? Cosine.
Oh.
What? You got it? You see what I'm saying?
Yeah.
Okay, by the way, those fundamental identities are right here in the back of your book, okay? So look.
I just feel like that's cheating. I can't
It's
bring
not
myself to
cheating.
look
It's
in the
not.
back of
Look,
the book.
I would, listen, I'll tell you, no matter what would have happened this semester, and every semester I've been teaching since the dark ages, I've given people on the front page of their test this thing right here.
Okay.
So do not worry about it, okay?
Okay.
All right. So that's going to be cosine squared. Okay. I'm feeling better about this one. How do you integrate cosine squared?
Don't we
What
gotta use that
section?
little formula from
Say it again.
9.2?
Yeah. What section do you think this is going to be in the book? The section on what? You don't need to know the number of the section, but the section on where we did what?
Where we were like, oh, the half angle stuff?
Yes, where we were, you know, it was a listing of things. If you have an even power of cosine, then go to a half angle formula right here, okay? And that half angle formula says,
1/2 something?
yeah, it's 1/2 something. It's 1/2, what is that, a cosine? It's
Yeah.
1/2, we'll move it up. Okay, it's shucks, hang on. It's actually 1 plus the cosine of, you take this angle theta right here and it doubles. In other words, this is half of what you get there, and there's a 2 down there. Go to the book, go to look at that, say, oh, I think that was some kind of formula. Let me see. In my notes and in the notes in the book, and in the text in the book, it'll tell you what to do. So that's not bad. Because if I pull that 1/2 out, I've got 1 plus cosine 2 theta. That's 1/2. All right, what's the integral of 1 with respect to theta?
Theta.
Theta. So naked theta, remember?
Mm-hmm.
What's the integral of cosine 2 theta, guys?
That's another one of those formulas, right?
No, not really, because it's just the
No.
cosine of a constant times that.
Oh, so sine.
Sine of what?
2 theta.
2 theta, but instead of multiplying by 2, I'm going to do what?
Divide by 2.
I'm going to divide by 2. Now, there is a little trick here I got to finish up. Alexis, you see, there's a lot here, okay? But do you see how I'm going step to step? This is all the stuff you can look at. You can say, what happened when we did that?
It's just a lot.
It's a lot. It is a lot. But let me show you one more thing. So now, I mean, I'm done, guys, except for the plus C, which I still forgetting 40 years later. Okay, plus C. What do I have to do at this point, guys? I'm done with the calculus. What do I have to do?
The theta.
I have to go up to the, ooh, I didn't draw it, did I? I didn't draw the triangle. Let's draw the triangle. There's theta. That tangent is opposite. So x plus 2 over adjacent, which is x plus 2 over 1. And then this thing right here will be the square root of x squared plus 4x plus 5. See how it's coming back to you? And it always, in some form, it comes back to you. So I think I can get everything I need from the triangle, except there is a little bit of a hitch here. Let me go down here. One half. Theta, remember up from up here, x plus 2 was tangent theta. Oh, shoot. X plus 2 was tangent theta. So what's theta? How do you undo a theta to get what theta is?
The inverse.
Yeah, it's going to be inverse tangent of x plus
2.
Yeah. So there's that one. Now, here's where there's a little bit of a, it's this a little funky. So look at that thing right there. That's not in my triangle. What's in my triangle is theta, not 2 theta. So I need to figure out a way to change sine of 2 theta to just something in terms of thetas. Do you know a way to change the sine of 2 theta into things that just have a single theta in them? That's a double angle formula, guys. Would Dr. Maddox have expected you to know that? What's the sine of, I know you probably did this. What's the sine of 2 theta? If you don't remember it, it's 2 sine theta cosine.
Oh, cosine theta.
Yes. See all these little things that are coming up? But they're all things you should know. You're working at a high level here when you start seeing all these things. And the only thing that can make you get to that level is practice. So this is going to be the 2 from here. Now let's look at and see what sine theta was. Where am I going to pick up sine theta?
The triangle.
Triangle. It's going to be x plus 2 over this thing. So that's going to be x plus 2
over the square root of x squared plus
Thank
4x plus 5.
Square root of x squared plus 4x plus 5. I'm getting kind of out here. The cosine of theta, go back up here. What's the cosine of theta going to be?
1 over the square root of
X,
x squared plus dot, dot,
right.
dot.
So cosine is adjacent over hypotenuse. Okay, so that'll be 1 over another one, square root of x squared plus 4x plus 5. And if I'm rewriting that, guys, a square root times a square root is just going to be that thing down there. So the final answer looks like inverse tangent of x over 2. The 2's cancel. It's going to be x plus 2. When you multiply these two radicals together, you'll just get x squared plus 4x plus 5 plus c. That's a good problem. It didn't work out like I wanted it initially because I really thought we were going to be in luck if this thing right here factored, but it didn't. That would have made it a partial fractions problem. Because it didn't factor, I had to do this complete the square on it. Now, Alexis, you got your hand on your forehead like you got a massive headache, okay? And you may have, I don't know. But do you sort of see what I'm doing?
I see, but I'm just overwhelmed.
I know. Look, this whole chapter, you can't say, I'm going to learn this section, then I'm going to forget that and go to the next section. Because they're little pieces of it.
This like back to back, and then like I did the wrong work, so I was just rushing, and then everyone's just giving a lot of quizzes. Like organics giving like a quiz this week, solutions giving a quiz. I have a project to do in environmental studies. It's just a lot.
Okay. Do that little short quiz on 9.2, and then look at as many of these as you can. That's all I can say. That little short quiz in 9.2 had 3. Did it have 3 problems on it or 4 problems?
I think it's like 3.
Okay, I will try. And when did I have it due? When did I say? I said today. By tomorrow by class time. Okay, so maybe that'll give you some extra time. Would you still be having quizzes if we were in regular class at school? Would you be having, I know you'd be having all the quizzes I'm giving you because I was giving you quizzes anyway, but are they doing extra quizzes in chemistry and different other classes that you probably wouldn't have had them?
Yeah, like organic, he's giving us like a quiz every week, and usually he never gave like quizzes every week. We always had like tests.
Yeah.
But every week. So, and then solutions, we had quizzes like every like 1 out of 3 weeks because he like only had 2 exams last year and like 1 final. And then environmental studies, she's just, I don't know what she's doing.
Okay. Who's doing environmental studies?
Her name's Rami Karna.
Rami. Okay. All right.
She's an adjunct.
Yeah.
I really don't know what's her last name though.
Okay, that's fine. It does seem like everybody's kind of loading it on, and the reason is I think they want to make sure you don't get behind on this stuff, and maybe because if you get to a certain point and you're behind when it's online like this, it's it's hard to go back. So kind of try to pace yourself a lot sometimes, and I'm giving you a lot too. And this chapter is one of the harder chapters that we would do in this book. I'm really sorry we got interrupted in the middle of it, but I think I hope you're beginning to see it's a lot of different methods, and you can use them a lot during any one problem.
I think I just keep about not seeing it correctly because the number 2 one that I asked, I started off right and then I did the wrong type of, I forgot what I did, but I did long division, but I didn't use the right numbers.
Okay.
And then the only ones that I was able to get by myself was number 3, and I did it differently. Like I did split up the signs, and I'm pretty sure now it's wrong.
Well,
I
try
got
it again. Yeah.
number 14 and I started off 13, but I didn't get much further.
Okay.
And
All right.
I totally messed up number 8 because I just kept splitting them up. Like I was just like, oh, I can make this into secant square. So I really don't know.
This is all about learning from your mistakes. Normally, this assignment, I would have paired you up, and you would have helped each other. You didn't have that help here. You had to do it on your own. So I'm doing more in class than I maybe normally would have done. So, but like, remember things like, oh, when we had that cube root there, oh, that's not going to be a trig substitution. Make notes to yourself, okay? Go over the ones that we've done, looking at the video, saying, I need to remember that. Write it down. Because you're going to be able to look at that stuff and ask yourself, what do I need to do on this problem? And I know it seems overwhelming at this point. All I can say is do the best you can, and we'll work it out. But you know, if you come to one you can't do, I'll be glad to give you hints on it, and then we'll follow up later. Whether we follow up individually I haven't scheduled my office hours yet, so if I can find another hour in the week, I'll do office hours, and we can do things individually if you want to. Okay, if there are things you're stuck on, that doesn't solve your time crunch. Okay, because you're saying, oh God, she's adding another hour on. But more than anything, and it's affecting me too, usually I grab my calculus book, I go into class, I give you a lecture that's right here in my head. Right now, what I'm having to do is write down every single thing I want to do. So it's taking me 4 times as long to do what I normally would do, okay? It's affecting you guys, and it's affecting me and every other professor, okay? So let's keep telling me how you're feeling, okay? Because that's going to help me to kind of judge what I need to do. Maybe on a quiz, maybe I only need to give you 2 problems instead of 4, okay? And I'll certainly keep that in mind. The reason I give 4 usually is because I'll see different things that happen in things, but it'll force you to look at different things. So I don't know if that makes you feel any better or not, but we're all kind of struggling here for whatever.
It's just these problems take longer to do, and I know we can't make the class time longer. Like I just feel like because like as we keep going higher in the math levels, like the problems take longer to do.
They do.
So
Absolutely.
That means like we only get like, you know, a decent amount of good examples, but then when we do the problems in the book, there might be something we haven't seen yet. So then we're spending like 2 hours. Like what I do is when I can't figure something out, I keep trying to do it and over again until I get frustrated.
Okay.
So then like that takes up time, and then I'm like, oh, I didn't do this work. So then I'm like staying up until 2.
Yeah.
Even when I slept till like 2, I still didn't get done with the math homework. So I just went to sleep. And I woke up in the morning and I still couldn't get done.
That's okay. That is okay. Maybe what I need to do on the test, and y'all remind me of this, is maybe I need to give it to you on a Friday and let you have 3 days to do it.
I have like
No, please don't.
Okay.
Organic quizzes are every Friday, and then line barrier is doing quizzes on Friday until like the week before Good Friday. No, the week after Good Friday. After Good Friday, he's making them on Monday.
Okay.
But he's also doing quizzes on the weekends. So I'm just.
Okay. All right. That's the kind of stuff I need to know. And when I start to give you like a bigger test, like the test on these integrals, we will together, the 4 of us, 5 of us, we'll sit down and say what's going to work in terms of time.
Yeah.
And I'll try to be as sensitive as I can to that. I'm going to try to give you additional options. Like I said, I'll give you 12 integrals, and I say do 10 of them. I'll give you credit for other 2. So if you get stuck on one, you can try another one. Hopefully you don't get stuck on everything. I had a test one time in graduate school. I got stuck on everything. And the professor he said, if you want to sell me your points, you can sell me your points, and then I'll give you a hint. In other words, we had to buy hints and lose points. Well, you know, I kept going up there and up there and up there, and I was like, dang, I'm not going to have no points left on this test if I keep going up there selling points. It's a weird thing. But the higher you go in mathematics, the more involved it gets. You can see that in Calc 2, I need everything I did in algebra. I need factoring. I need all of that. From Calc 1, I need derivatives. I need basic integrals. From trig, I need this, I need that. That's what happens in mathematics. Do not get discouraged because that happens to everybody. And listen, guys, I did not make an A in this course in college. This course is hard. It is hard, okay? And I don't think I'm particularly smarter than you guys are, okay? I've just had more experience than you've had, but you can't get frustrated to the point where you just throw
You're
your
smarter
hands up.
than us.
Also, I had
I'll
a
tell you
question
that.
about, like, the pass fail thing. So, like, if we don't, because I can't have another C
Well,
on my transfer. Like, it can't happen. I can't
All right.
have a C. So if I end up getting a C, but I already asked to have my grades in April pass. Like, are we able to go back to pass fail?
yes, you can do, yes, I can do that.
So even if we fill that form out, we can still do
Look.
that.
Well, if you fill that form out that you want to grade and you get a C and you would rather have a pass than a C, after the semester, I can go in and I can change it.
Yeah,
That's
because
a
I can't
lot.
have no C's. Like, my GPA already looking kind of not bad, but it's not what I want it to be. And if there's another C, it's going to go down the drain.
Okay, that's, you don't, well, first of all, you don't have a C right now, okay? I didn't send in a deficiency for you. Nobody that, I mean, y'all had A's and B's, okay? So, and I want you to remember how you felt when we first did trig substitutions. And you're like, oh my God, you didn't understand it for a while, okay? But once we started doing it more, you understood it, okay? It takes time. And I know you're thinking, I don't have a lot of time here, but just try the best you can, do as much as you can, okay? I can't help you with your other classes. God knows you guys know more about chemistry than I do right now, so I can't help you with that. But we can sort of pace things and figure out what's going on in here. But don't get frustrated. Plus, there's partial credit for this. If you get halfway down the road and you say,
Abort,
I don't know what
abort.
to do next. Try it. Just do as much as you can. Okay? Back off of it. Go have a whatever you can do that's fun at home. You know, I don't know what to tell you. I don't have a whole lot that's fun here to do except go in the freezer and eat some ice cream, and that means I'm just gaining weight at a rate of change that is really high. Okay? I'm sitting on my butt and I'm eating ice cream and potato chips.
I mean, ice cream and brownies.
Yeah. See?
I'm lactose intolerant.
So, well, you got a problem with the ice cream then. But anyway, and y'all can work it off. I'm at the age where when I put it on, I don't know where it's going to go, but it ain't going to go anywhere really. But anyway, so I'm just trying to keep your spirits up, okay? Because this is what we're doing is tough. What we're doing is really tough. And I'll do whatever I can to help out. But I think you guys are doing well. I really do. But what we've got here is something you can look at when you try to do other problems and say, man, why don't I try this? Why don't I try that? And that in itself is hard because you might sort of want to give up after the first thing didn't work. You don't want to do that. You want to try something else or either keep going. Okay?
It's crazy because I looked at that paper that we did today in class
Mm-hmm.
and I didn't know what to do. Like mine was blank. Then you pull it up on here and I'm like, oh, we could do that. Oh, we could do that.
Okay. I don't
When I'm by
know.
myself, I don't know what to do.
Well, that's why the art of doing mathematics is asking yourself the right questions. And I want you to look at that integral guide sheet that I put on Moodle. It'll say, here's what you have when you have, something you can factor in the denominator. Try partial fractions. If you have something that looks like x, e to the x, try parts. It'll sort of outline your thoughts. It'll organize your thoughts. Okay, miscellaneous substitutions. I've given some. Have you guys looked at that by any chance?
I'm struggling with those.
I
That
looked
was my
at,
next
like,
question.
couple, but like I just been trying to do a little bit of everything.
Okay,
Like,
all right.
There's too much work going on, and I'm trying to figure out how to finish the work and go to bed and still make it to like an 8 o'clock in the morning Zoom.
Yeah, okay.
You know,
Yeah, this is
and
tough.
it's not mandatory, but it's like if I have questions, I'm going to go to it, and then we learn about like what he wants us to study for the quizzes and stuff. So like, I need to go.
Okay.
It's
Well,
expiring.
the problem with, it's not a problem, but the reality with people that are in science and mathematics is there are no slacker courses. There's no
Yeah.
slacker courses, and you guys know that. So, so just do the best you can for right now. And Tara, what did you just ask me? You asked me something. I can't remember what it was.
About the miscellaneous substitution.
Uh-huh.
Yes.
You got another one? Another
Yes,
one you wanna
I
ask me
do.
about? Okay. Alexis, you may have better ways to spend your time, but I'm gonna answer Tiara's question, okay? If you want to
I'm
see
about
it.
to go.
Okay. All right, that's fine. If you have to go, you'll see this online. You'll see this on the video, okay? Thank God I have all the minutes I want for the video now.
Bye.
You're not gonna cut me off.
Bye,
Okay.
y'all.
Bye.
All right, look, try to ease back and do what you can. Worst things are happening out there. One of my good friends died this morning, and
Gosh.
he doesn't have COVID, but he's a little older. He taught at Salem for 40 years, and I did a lot with him, and that kind of puts everything in perspective. You know, do the best you can on this stuff. Okay, there's worse things that can happen. Okay, all right. So take care, and I'll see you tomorrow. Okay, Alexis.
Okay, see you
Okay.
tomorrow.
Okay. All right, Tara. Tell me what you got.
Okay, I tried this twice. I tried it 2 different ways.
Okay.
I didn't get the right answer at all.
Hey, tell me where the problem is and what it is.
Number 3,
Okay. Page what?
I have no idea. Just at like 479. Oh yeah, it's on page 485.
Okay. 485. Okay. Okay. That's one of the ones I tore out. Okay. Oh, I got it. Number which one? 3?
Yes.
Okay, good. X over the 5th root of 3x plus 2.
Yes.
That the one?
Yes.
All right. I want you to tell me what you tried.
Well, I tried, doing like making that entire denominator u.
I like that. Let's do it. I like that. Okay. What do you think I should do now? That's a good idea. What do you think I should do now?
And then I don't really know how to say this. I don't want to say I fifth both sides, but
And that makes perfect sense to me. You fifth both sides. I would probably say you raised both sides to the 5th power.
Yes, I like that better.
Yes, I get it. Okay, good. Next step, please.
And then I found the derivative.
Okay, right. So what's this on the left?
5u to the 4th.
Du equal what?
3.
3 what?
Dx.
Thank you.
Oh.
So I got to substitute for dx. So what do I want to do with that 3?
Move it over and make it 5/3 u to the 4th du.
Perfect. Okay. Now I'm gonna try to start substituting and see if I'm making any progress here.
Okay.
Dx is u to the 4th du. I'm gonna pull that 5/3 out. Don't need it. Inside anyway. Then I'm gonna put in the bottom, what goes in the place of this 5th root of 3x plus 2?
U?
Look at what you got here.
That's a lot of stuff.
What's the 5th root of 3x plus 2?
U?
Yep. That's why you let it be u. So you would get a monomial down there. All right, let's look at the next. What's the only thing left I've got to substitute for? I did dx. I did this. What else have I got to substitute for?
X.
X. Can I get a handle on x from anything in here?
Yeah.
Tell me what.
We can look at the u to the 5th one.
Good. So u to the 5th minus 2 is 3x. That says x is u to the 5th minus 2
divided by 3.
Perfect. All right, let's do it. You're doing the right things, okay? Here's what I want you to do. I want you to imagine I'm asking you the questions, and you ask them of yourself, okay? Because you got all the right answers. You're just not asking the questions. All right. So I'm going to do a little more work here, by the way. Hey, why don't I just say well, whatever. This 1/3 right here is going to come out. So that takes care of that 1/3 there. And then I'll have u to the 5th minus 2 times u to the 4th over u. All right, I want you to tell me what you're going to do next.
We can distribute the u to the 4th inside those parentheses.
Okay, I'll do that. I was thinking something different, but that might work. Let's try.
No, I still don't
So-
match that.
So, and I actually, it will work. I think it's a step you might not have to make, but we're going to try it. U to the 9th minus 2u to the 4th over u du. Actually, I like that. See anything else you want to do?
Yeah.
Yeah,
I
what?
think. Well, all of those, well, the u can go into all of those.
Yay! And what do you get?
U to the 8th
Mm-hmm.
minus 2u cubed
Now,
du.
you think you can handle that?
Yeah.
What's the integral?
U to the 9th over 9 minus 2 u to the 4th over 4. And that'll reduce down to 1 minus 1/2.
Yep. And then what are you going to do after that?
Plus c, and then plug back in your u.
Yeah, and remember, my u, this isn't going to be pretty in the end, but my u was I forgot what u was.
It was the 5th root 3x plus
5th
2.
root of 3x plus 2?
Yes.
3x plus 2. Everywhere there's a u in here,
You plug that in.
put it in and you got it. Now, I'll tell you what I was going to do. What you did is perfect. What I was going to do is, since these were already in factored form, I was going to take, I was going to just go ahead and divide this. And u to the 4th over, and it would have been u cubed. It still would have been u to the 8th minus 2u cubed. It doesn't matter. You went the way you wanted to go. I went the way I wanted to go. They're equivalent. They're equivalent. So you see, you did exactly what you, tell me why, you said you got stuck, but you gave me exactly the right idea up here. That's a new problem. Boy, this is going to look horrible. That's a new problem right there. You gave me exactly the right idea. What did you do after that? After you already had that idea, what'd you do?
I don't even know what I did. I mean, I have all of that stuff that's in this circle, you know, all that u stuff all the way down to the 5/3.
Good.
And then I want to go back and plug it in. And
Well, okay. So you got to figure out.
oh, I know where I messed up. So you know how when we first learned how to do u substitution, and we just was like, oh, this equals u, blah blah blah, and then we put whatever coefficient was left and put it outside,
And that's all you did.
yeah, but I made the error, and in my denominator, I have u to the 1/5.
Oh. Okay. Well, no. It's because you let that be u.
Exactly. I let the whole thing be u, not
So
just
you
the inside.
Okay. So you just made an error when you move these things over to the substitution. Be careful, because you let u be this whole thing. So that's what you want to put back there. Okay. That's a mistake you learn from. That's a mistake you learn from. It was true that if u were 3x plus 2, I might have a u to the 1/5, but I let u be the 5th root of that because I didn't want to deal with that 1/5 thing. I didn't want to deal with it. So I raised both sides to the 5th power, and then I didn't have to deal with a root anymore. This is what's called changing a radical form into a polynomial form. And or that's what I call it. And it makes things easier. Let me see what I did after that. I put it in, yeah, so right here. Okay, so there's what x was. Okay, so
That makes way more
how I
sense.
I found it from that. Boy, they're gonna look at this and say, what in the world? Okay. But you see what happened, don't you?
Yeah.
Okay. What else you got?
Oh, how you know I had something else?
I knew you had something else. What you got?
Okay, number 9.
Number 9 on what page?
The same page.
Same page. All right.
I try not to give up. I was like, let me go to the next one.
All right, let's see how good your instincts are. Number 9, tell me the page again. 484, 485?
485, yes.
All right, let me look at it. Okay, there's my torn up book. It was 485, number 9.
Yes.
Oh, interesting.
Yeah, very interesting, actually.
Dx over x plus 1 times the square root of x minus 2. Now, first of all, I want you to tell me why this isn't a partial fractions problem.
Because the square root x minus 2?
Yeah. Alexis, if you're watching this online, that's because it's got a square root on it. Okay? So to me, it seems like the problem is the square root thing, right?
Yeah.
And if I need to somehow let u be something that eliminates that square root somehow. So what's your idea?
So wait, would the u just be that square root x minus 2?
Let's try it. There are no definitive answers here. It's just what works. So now what would you do with that?
Square both sides.
Thank you. Okay, so it's squared. Tell me what your next step is.
So now we know that 2u is du is equal to.
Wait a minute, I messed up. 2u du is equal to what?
1 dx.
1 dx.
Oh, wow.
Oh, wow. All right. So you think you got enough to try to start substituting?
I mean, we can. Well, what will we do about the x plus 1?
I know what x is. Look up here. If you've got anything in this circle that allows you to put something in the place of x.
Okay, don't just forget I ever said that.
I'm just asking again, okay? You'll remember this. Trust me, okay? So now I've got, let's do it. What's dx?
1. Two du.
Yeah, that's all the stuff in the circle.
Oh.
Okay. All right. What's the square root of x minus 2? Look in the circle.
U squared.
No. What's the square root? What did you?
Oh, u.
See,
Sorry,
there you go.
I was looking below that.
Now we got this x plus 1. But what do I know x is here? Look at the circle.
U squared plus 2.
Yeah. So x is u squared plus 2. So x plus 1 is going to be u squared plus 2 plus 1, which is u squared plus 3. U squared plus 3 times u. Okay. Did I get it right? U, and then there's u squared plus 3. That was u squared, wait a minute, x plus 1. So that was u squared plus 2 plus 1 is 3. Okay. All right, so, okay. Look at it and think about it.
What I'm thinking about.
No, it has u's in it instead of x's, but you know what? It's not going to be a different problem because it is a rational function. What do you do with a rational function?
Please don't tell me we're about to do partial fractions.
I'm going to tell you we're about to do partial fractions, okay? You should say, oh, goody, we're about to do partial fractions because you got the right answer, okay? One of my friends, who has gone to math heaven now, used to say, what do you say to a mathematician when somebody says, I've got problems for you? The mathematician says, goody, goody, I love problems. Okay, that's goofy, but anyway, here we go. Okay, you want to do partial fractions? We're going to do it, because I think that's a good idea. How you going to set it up?
You know, well, okay, so it's going to be, okay, that's irreducible, so it's going to be, does it matter which order we write it in?
No, not at all.
Okay, so we can do A over U, or U over A, or A
well,
over
it's
U.
A over U. I buy that. What about the next piece? So you took care of that piece.
B X U B U plus C.
Yeah.
Or that.
It's got a U in it instead of X. No biggie. BU plus C. Okay. Let's see if we can do it, okay? But you're right. It's a partial fractions. It's a partial fractions. I'm going here. Okay, so let's break it down. This is going to be 2U. I'm getting sloppy here. Because we're both tired, I think. But we got the 2U and the U squared plus 3 and the U. And that's A over U plus BU plus C over U squared plus 3. And then if I multiply through, oh, what am I doing?
Wait. Shouldn't it be equal to 2U?
It is 2. Let's come back. Isn't this 2U right here?
Right there?
Yeah. Is that 2U or 2DU? Let me look. It's 2U, isn't it?
Yeah, 2U DU.
I don't want to use partial fractions. You're right.
Thank you. Jeez.
Okay. But because what happens to these U's right here?
No. Yeah. Oh, they cancel. There's no more U's. And then it's 2 over U squared plus 3.
All right. Okay, now we're going. Okay, so see, I miss things too. Okay, so those U's are gone. Forget all this. Okay, I don't want to do that. Because the U's, that's a 2. That's a lousy 2. But they go. And now, I don't want to do that. So what I get is integrating, I can't get used to this, is 2 over U squared plus 3. Now, that's assuming I hadn't made any mistakes, but we'll look at it and see. Now, here's another learning point. What's it look like to you? What's it look like to you? First, I can pull the 2 out, so I'm not worried about that.
Yeah.
So it's U squared plus 3. There may be a glitch in it, but tell me what it looks like to you.
A log?
Doesn't look like a log. Why?
So what?
You would need to have a U up here to make it a log.
Yeah, but
So what's it look like? What if I did this? What if I said U squared plus 4? What would it make it look like then?
Trig substitution?
Yes. And you know what? I don't have to have a perfect log there. I could write this like this.
Well, that makes sense. That's why they had a √3 in the back of the book.
Yeah, so because it's √3 squared.
Oh.
Look, they've been being nice to you up until now, okay? They've given you all these nice perfect squares. They're not all perfect. So now you tell me what you want U to be. If you think, if it's a trig substitution, tell me what trig substitution you think it is.
Well, I know it's tangent.
It is. So your A is √3 tangent
theta.
Tangent theta, yeah. Now just do your DUs, put it all in, and integrate the thing. So when I said you got a learning experience here, it's that this doesn't have to be a perfect square because you can always write a square root squared. So
Yeah.
that's your A. That's your A. You're doing good, Tierra. You're doing really good. You got the right ideas. You just have to learn to persist, okay?
Yeah, because I keep getting close, but
You're getting darn close, okay? And the places where you're getting hung up
it's
are
the same
maybe things that
parts.
you hadn't seen. Yeah.
Okay.
Same thing. You know, it's like that's why you do homework.
Catching up on homework. But
What?
okay, so how do I word this? What would this problem need to look like for us that use partial fractions?
You would have had to factor this. So for example, suppose it had been this. This is just a suppose. Suppose it had been 2 over u squared minus 3. And I'll put a little wrinkle in it again. You could have factored that into u minus root 3 times u plus root 3. You know, I take it easy on the people in algebra because I got people in there that are going to freak out on me, okay? But that works, doesn't it? I mean,
Yeah.
the inner and the outer drop. Root 3, that's the square root of 3. That's 3. That's the square root of 9, which is 3. If that looked like that, I'd make this a partial fractions problem. Or it would work as a partial fractions problem. It would also work as a secant. An inverse, let u equal square root of 3 secant theta. See that form? See that u squared minus 3? You could use partial fractions,
yeah.
or you could use another trig substitution on it.
Okay.
You got options, but don't get tangled up in your options. Go down one road and say, just try to persist. If it really looks impossible at some point, say, did I have another option? Am I going down the wrong road here? It's going to be a partial fractions, Tierra, when this thing down here will factor.
Mm-hmm.
Or maybe if it's a trig substitution, if it's a nice thing like u squared minus a squared, or a squared minus u squared, or a squared plus u squared, you got options there. Okay, so maybe you try partial fractions or partial fracs or inverse secant theta as a substitution. So when Alexis always asks me, and she's got a great point, let me put that back, about why does anybody do any of this? In reality, if I were an engineer or whatever, and I needed to do a certain integral to figure something out, like the volume of this tank I'm dealing with or whatever, they would get to this thing right here and they'd say, I learned that in Calc 2. But you know what? I got a package on my computer that'll integrate it for me. They're going to put it in the computer and get it to integrate it, okay? So you go through the tough stuff in here, and then when you use it later on, you're like, yeah, I understand what you would do, but I don't have time to do that.
Yeah.
If I had time right now and the resources, which I don't, we would be doing some of this stuff using tables or using Maple. But y'all don't have access to Maple, so I have to kind of give that up right now. But that's sort of what might happen in reality if somebody had to work with this. But you guys are doing it all by hand. I sometimes on the test, I'll say, here's 12 integrals, do 10. Anyone you using Maple, I'll give you half credit. Okay, that kind of thing. You see what I'm saying?
Yeah.
So there you go. That's what we're looking at. Do I dare ask you if you could have another one?
No. At that point, I just gave up. I was like, you know what? It's 1 o'clock. I'm done.
I get it. I mean, you need to get some rest too. You really need to get some rest too. So just do. And Alexis is a worrier. You're a worrier. I know the two of you very well because I've known you since, now 20.
That's fair.
All right.
Fair.
So just get, I know you can do it. I know you can do it. All right.
See.
You okay?
Yep. I need a
What-
nap.
What you need a nap? I was going to ask you what you were going to go work on, but I think you might need a nap.
Oh, I need a nap. I've been in class since 8 o'clock, and I took
Okay,
a nap
you need
after
a nap.
each one.
You're right. You're right. You go take a nap, okay?
I will.
Okay. Look, I'll see you tomorrow, okay?
Okay. Bye.
Okay. Bye.